Good morning, welcome to a very special day. I'm Aisha Evans, CEO at ZOOX.
And I'm Jesse Levinson, CTO and co-founder of ZOOX. We started the company 6 years ago to create a cleaner, safer, and more enjoyable way for people to move around cities. And we're really excited to share that with you today.
At ZOOX, from the beginning, we set out to reinvent personal transportation, making it cleaner, safer, and more enjoyable for everyone.
And today, we are announcing and showing that vehicle. We've been working on it for over 6 years now, and it is the first vehicle that's been designed from the ground up to move people autonomously around cities. It's bi-directional, it's symmetrical, it's fully electric, and it's fully autonomous. You can't drive it, there's no steering wheel. It's designed for riders, not for drivers.
We believe that designing from the ground up is the right way to combine AI and a purpose-built vehicle that combine and make it easier to optimize to achieve the best results.
ZOOX is developing a better way to go from A to B in dense urban areas. And we're doing this through autonomous technology, ground-up vehicle design, as well as the service to back that up.
One thing that most OEMs are doing when they approach designing a new vehicle is they iterate on something that's been done before. That's good. I mean, there's lots of history there. It means evolution rather than revolution. But it's very rare that you get the chance in an automotive career to start from a blank sheet of paper. This was that opportunity. And that's because it doesn't make sense to take what's been developed for the last 100 years to solve, conventional human driving. It doesn't make sense to take that platform and to use that platform for what comes as the third generation of autonomous driving. ZOOX has chosen to develop a vehicle from the ground up for autonomy because we firmly believe that simply putting sensors onto a current passenger car is fundamentally flawed. It's fundamentally flawed in that the current geometry, shape, if you like, of a vehicle doesn't allow you to place sensors in the optimum position. So when you start sitting back saying, well, what do I need to enable autonomy? I need EV, I need optimum sensor positions, and I need a large battery to be able to deploy for the day. If you take all those three factors, you have to develop a vehicle from the ground up, leapfrogging the rest of the industry and go straight for that third generation of vehicle, which is EV and autonomous. Looking to the future, solving it now rather than iterating on the current platform.
Looks good. Fast.
Beautiful.
Designing a vehicle or a product really for autonomous ride sharing is definitely different than a personally owned vehicle. We understand first and foremost who the vehicle is going to be used for, and then we design the vehicle for that person and the environment. And the way we're using it for denser mobility as a ride hailing service, we really want to understand what the customer's needs are. And for those customers in those areas, it's pretty short rides, and so they're hopping on and off. And really we want to give them a safe, consistent ride experience. At the same time, something that's really delightful. Part of taking advantage of self-driving technology is letting humans interact the way we're supposed to interact, and that's face-to-face. So we've developed kind of communal seating. If you're by yourself, you have plenty of space. If you're with friends or family, you're going to be sitting close to them and interact with them the way you should be. And that's really how we designed that vehicle to be. We really wanted to be human-focused, to be able to take advantage of what self-driving technology can give us on the interior of the vehicle. The vehicle is symmetrical in its design because our focus is on the interior, and on the exterior we want to have consistent design for our sensor pods. And then we also have the exposed wheels, kind of more of a carriage type of visual. One, it makes the vehicle a little bit small on the outsides. It's also just very maneuverable. So we have front and rear steer that allows us to have a very tight turning circle. And bidirectionality offers us some unique advantages in certain scenarios, say a parking lot pickup and drop off, a parking garage pickup and drop off, or a hotel pickup and drop off, where the vehicle can just drive in. It can stop, it can be there waiting for you, you can get in the right direction, and then it can just take off. So we're just reducing three-point turns or U-turns and making your ride more efficient.
To be able to drive safely in the city, you need unrivaled visibility, if you like. So our sensor suite that we have, which is a combination of LiDAR, radar, cameras, need to be able to see 360 degrees around the vehicle, but more importantly, need to be able to see as early as possible. So as we come up to traffic junctions, as we come up to overtake vehicles, you'll notice we've positioned the sensors to give that visibility as early as possible. That means that our vehicle is seeing more than the human can see, and that enables it to deploy and operate safely. Our current L3 fleet are Toyota Highlanders. They're deployed already, operating in the cities, driving in the cities. That's all visible online. Anyone can jump online and take a look at that. The sensor positions on those vehicles are almost identical to the sensor positions we have on our L5 vehicle. And that's super important because it means that the testing that's being done in the mega cities is basically a substitute of our own vehicle being in that situation. And geometrically identical sensor positions means that any development that we do on the L3 Highlanders and any of the driving we do is directly transferable to our vehicle. So the vehicle you see behind me here, these are our first vehicles built off our production tooling. We went through the prototyping phase on the previous generation. We proved out that design. We're now building these vehicles off those production tools, and these vehicles will go through the same rigorous testing and certification to the Federal Motor Vehicle Safety Standards. The vehicle is designed to operate up to 75 miles an hour, which means that it's highway capable. And it can do that in either direction, being fully bidirectional. And that's been proven out on private test tracks. The next few years at ZOOX is going to be super exciting. First step, obviously, was we get to reveal the vehicle and show the world what we've been working on. The team's going to be super motivated by that.
You know, we were one of the first to commit to a ground-up vehicle design to support self-driving technology. I think that's helped accelerate us and allow us to get our vehicle on public roads sooner than maybe the public had imagined.
So at ZOOX, our artificial intelligence gets better every couple of weeks because we're constantly testing and training in some of the hardest urban environments. We've specifically focused for now on San Francisco and Las Vegas, which are two great markets for robotaxis and wonderful places to learn how to drive. Our vehicles are powered by a custom sensor architecture, very advanced compute, and also hundreds of thousands of hours of simulations that go even beyond what we're able to test and experience in real life. So let's talk some more about how that works.
Hi, my name is Ashu Rege, and I'm the SVP of software at ZOOX. The reason that ZOOX built its own AI stack is because when we started this mission, it was an open, unsolved problem, and we put together a team to actually solve one of the hardest problems known to man. What we have built within our AI stack is a prediction module that takes into account the behaviors of all the entities around us, which we are tracking over a time frame, and that just like humans can anticipate what other entities like other cars and people might do, our AI is also learning how to do the same thing. So when ZOOX comes to a new area, like a new city, for example, we will send a fleet of level 3 vehicles, a few cars, that will go and collect all the sensor data that we need to create our HD 3D maps. Once those maps are created, we build on top of that what's called ZOOX Road Network, which is the semantic information like traffic lights or stop signs. And that takes a matter of a few days to build that. And once that is done, our vehicles can then go and drive autonomously over there. As ZOOX drives more, it gets smarter by collecting more data. As we encounter more incidents, we will process that data offline, and our engineers will obviously take a look at what situations it was able to handle well, what it wasn't able to handle as well, and that gets folded into our development process where we would train our AI better with these specific corner cases, as well as validate our safety systems, for example, across all of these incidents that we might encounter while we are still in the testing and validation mode.
Have you ever wondered how ZOOX is able to drive autonomously? Just like human drivers, autonomous vehicles need to be able to see and understand their surroundings before navigating through the world. ZOOX does this using sensors, maps, and advanced software that handles perception, prediction, planning, and controls. Humans rely on eyesight to see, but ZOOX uses a state-of-the-art combination of camera, radar, and LiDAR situated on all 4 corners of the vehicle. Cameras detect color, which enables the vehicle to understand things such as the state of traffic lights. Radar bounces radio waves off surfaces to detect the distance, size, and speed of objects. LiDAR fires millions of laser signals per second, which reflect off objects and return to the vehicle, creating a highly accurate 3D model of the surroundings. Combined, these sensors create a 360-degree overlapping field of view, extending over 150 meters around the vehicle, enabling it to see in all conditions, including at night and in the rain and fog. Now that it can see its surroundings, the vehicle must understand its location. ZOOX drives within a predefined area, using a previously created geometric map, which shows a high-definition representation of the world. This, plus a semantic map, which shows things like speed limits, the location of traffic lights, and stop signs, is fed into the vehicle's powerful custom computer. The vehicle then aligns the sensor data to the map to localize itself and understand its exact location in the world. Knowing its location isn't enough, though. The vehicle must also understand what is going on around it. ZOOX's perception system fuses the information from all of the sensors to understand what is happening around the vehicle. A combination of approaches, ranging from geometric techniques to the latest in machine learning, are used to detect and classify people, cars, trucks, cyclists, and other objects. Next, ZOOX's prediction system processes this information to infer the future intentions of people and vehicles around it and determines what might happen next. For example, is this vehicle going to turn left? Is that pedestrian going to cross the road? Because there are many possible versions of the future, the vehicle accounts for multiple potential paths simultaneously. The planner is the decision maker of the system, taking the perception and prediction data and determining how to safely and comfortably drive. Because of the map, the vehicle knows which route to take to get from point A to point B. But how exactly? Should it change lanes? Should it slow down? Or should it accelerate? All of this information is fed into low-level controls, the software responsible for controlling the vehicle's acceleration, braking, and steering. This all happens within a fraction of a second as the vehicle is driving. And this is how ZOOX is able to safely navigate through the world.
Well, thanks so much for joining us today. It was our pleasure to share everything we've been working on with you.
On social media, we will be dropping a lot of content this week. Please go ahead and tune in. And, of course, check us out on ZOOX.com.
So this vehicle has never driven in the city before. And today, we're going to ride in it in downtown San Francisco. Aisha, are you ready?
Oui, je suis vraiment prête.
The world's first ground-up, purpose-built, autonomous electric vehicle. Autonomous driving is hard because you have to get hundreds, if not thousands of things right at the very same time. But if you do all of that, it actually feels pretty easy.
My favorite part of the vehicle design is that every time I'm in that vehicle, I actually don't think about driving. I'm being transported. It's magical.
My favorite design element is probably the wheels. I think they're pretty beautiful. One of the best things about our vehicle is that every single passenger gets the exact same experience because of the symmetry. So what's interesting is that even though we're trying a whole bunch of stuff in a dense urban environment, after about 10 or 20 seconds, it just feels like the most natural thing you've ever experienced.
The next step after today is to continue testing, both on private roads and public roads, and get to market in a dense urban environment and transport people in cities.